Hi everyone. This is a rather interesting problem that I came across in the end of the chapter 8. And the problem is really about using a card class, which was created before, so I already did that, and creating a deck of cards, 52 objects of the card class, and include methods to shuffle a deck, deal a card, report the number of cards, and it all looks like a very regular problem for this chapter. However, the interesting part about it, and that's what I will talk about in the end, is shuffle. So how do you shuffle properly, and how do you make sure that the outcomes of this shuffling are what they say in math or statistics evenly distributed? That is, every card combination shows up with equal chances. And that is the tricky part here, or something that is not quite what you can just do in some way and be sure that this is the fact. So the point of this video, the deeper part of this video, is how to shuffle. But let us check out what we have currently. So the card class works. I created a new instance of the card class and printed it out. So the toString method was called. Let us check out the card class. Two private attributes, value and suit, standard constructor, standard getValue method, and string suit is mapping the integers. You see that I created the suits as integer values, mapping the integers to their actual names. And finally, the toString method, the results of which you see over here, is just making a nice printing statement. So going back here, I need my deck of cards have 52 objects of the card class, and that is a natural reason to use arrays. Not array lists, but arrays. And then have the methods. So first of all, I need to create two private methods, card and also length. Oh, I forgot the name, deck. There should be a name. And private int count. Then we can generate a standard constructor, but we really don't need to, because the behavior of a constructor should be different. We should start with a full deck, and the count will actually be 52. So count is 52. That's easy to fix. And the deck is something that we need to create. So this is new. New card 52. And now we need to populate the deck with actual cards, with actual card objects. And I'm doing that with a for loop for int I from 1, because the actual values for the card class value from 1 to 13 and suit from 1 to 4. So I less than 53. In this case, this is all constant, so we really know what are the upper limits. We should go from 1 to 52 including I plus plus, no, 13. And the inner loop for int j equals 1, j less than 30, less than 5, and here 13 should be included. So I'll go back and make it 14. This is 5 because there is 4 decks, so it's going to be 1, 2, 3, 4 for J. And J++, okay. So this deck dot and here is the issue. We should run through the corresponding indices in the deck, and for each of them we should create a new card with arguments I and j. And what do we put in here? So maybe take a moment in this video and figure out how you would do it. The math way would be to just make a formula using I and j, and it's a linear function, so it's not that hard. But a purely programming decision would be to introduce a k variable starting from 0 and throw in the k over here, and also do k++. Okay. And so this will be our constructor. Now it's populating a full deck. And we need a basic method such as deal. And this method will return a card object. So basically we need to return, and we need to return the last card on our deck. And how can we control it? So we can control it using the count. Every time we return a card, we reduce the count, and we use the count as index. So deal deck count. And maybe I want to do it, save it as a variable first, because I also need to reduce the count. Count minus minus. So reducing the count by 1. And actually that will work as it is. So Ctrl V, return deck. Because my count is 52 originally, I'm decreasing it by 1 first, so now I'm referencing 51. And that is the last element in the deck. And as I decrease it, the count will also be decreasing. So this looks okay to me. If we wanted to be more consistent, we could actually even replace the last element with the now, but in that case we would first save the last card and then return it and replace deck count with now. But okay, so let's not do that for this example. Deal a card and report the number of cards left. To report the number of cards left, I'm just creating a getter for count. Let me see what issues did IntelliJ find. Line 8, something is missing. Yep. And it's time to test our code and see if it works. So I will leave this for later. First of all, I will create a variable deck of cards, instance of the class deck of cards. Call it deck new deck of cards. Alright, and from this deck of cards, I'm gonna deal cards and print them. So remember how deal works, it kind of gives the last part, the last card. Okay, so deck dot deal, and this will print the this will actually, and first of all, deck.deal will return a card, and then we're basically calling this toString method on it, so there will be a string here. So how about I do it, say, 5 times? And then I'm returning the deck.getCount. And we don't need that anymore. So let us run and see if the deck works as we want it to do. And I did not do the method, the shuffle method. So suits are changing and the values stay the same, then suits go back to diamonds and the values reduced by 1. So this is how the tail end of our array of cards work. And that is because of the ordering of the for loops. So take a moment and think through that, why this is the last card. And I consider that we are done with it and it works correctly. So we removed 1, 2, 3, 4, 5 cards. 52 minus 5 is 47. So the card counter works as well. And the last but not least thing to do is to have a method to shuffle the deck. And I'm going to do it in a naive way. And first of all, we will see that it works. And second, I will show you, I will give you links and hints why this is not the best way to do it. Okay, so public void shuffle, and we only want to shuffle if it is a full deck. So if count not equal to 52, I need parentheses here, then I will not shuffle and I will say not a full deck. Not shuffled. And else I will shuffle. So how will I shuffle? Naive shuffling, I'm just going to take a pair of cards and swap them over at random. Well, I need to create a random object, so random gen equals to new random, and then I need a for loop, and for every value of index I will generate a random pairing, so random other index, and swap over the cards in the deck. So for I in, well, int I equals 0, I less than 52, well, we checked that the count is 52 for it to work, I less than count I plus plus, First of all, I will generate a random value k from the appropriate range gen next int, and the bound will be 52. We're dealing with indexes, so the indexes in my array will be from 0 to 51. Count. Okay. So I'm going to take the card I and save it as temporarily save it elsewhere. Card 1 equals to deck I. And I will say shortly why I'm doing that. And then I'm going to say that deck I is equal to deck J K. That is our random other card that we created the random index. So we took a card from that index. And finally, deck K equals to card 1. So I had to save this card because I was about to reassign deck I, and what this would literally do, in the beginning, deck I is holding a reference, an address of an object, card object number I. And if I were to just do that without the previous line, it would completely forget the deck I object, and it would basically create the reference to the very same object I once I say deck k equals to deck I. So without that line, this would not actually swap the cards. So this seems like a good method, and we will shortly test it, but warning, not a way to shuffle properly. So if you are writing an app for an online casino, don't use this method. Alright, this method will work and we will see nothing wrong. Well, maybe we will see some errors, but you cannot really see anything wrong by just doing rudimentary testing. Let's make sure it works, and to make sure it works, I'm going to actually include a line, a print line with some like delimiter, system, and I'll have a delimiter of stars dot repeat, and I will repeat it 30 times. So this will be a line of 30 stars, and maybe another delimiter. And then I'm going to get a new deck, repeat this same thing, only after shuffling. So here I shuffle, and I'm shuffling deck.shuffle. So I want to first check that my shuffle somehow works, and this is all effort to check it. So second time around, I should see a random sequence of cards. Here we are. Okay, first time we see the same thing. Let me expand that. That's what we expected. Second time we see what looks like a random shuffle of the cards. So my code works. It does change the order of the cards, and at the first glance it's all good. It's all good, and you would not be able to detect any abnormalities with like running this program several times, running this code several times. Here is an issue. When I'm doing the shuffling, my purpose is to create a completely random sequence. So the results of my shuffling have to be equally distributed, which really means there are equal chances to produce any sequence of cards. So that's how we need our shuffling to work. If we are doing it, say, for a casino or in general, there is plenty of different reasons to have like to control like outcomes with equal probability. And it turns out that this code does not do it, even though it does change the order of cards and it looks very strongly like a very natural thing to do, and also it looks like it produces random results. It does produce random results, but they are not evenly distributed, which means some outcomes are more likely than the other. Some sequence of cards is more likely to appear than the other, and that's not what, for example, a casino would want. And there is a very nice and rather old, apparently, blog post about it, describing how and why this happens. So it uses this word naive, which does not mean stupid, it means the first algorithm that you came up with, basically, or the easiest thing that you could come up with. And I think this algorithm basically does the same thing as what I was doing, and maybe there is a slightly different backend to it, but that shouldn't worry you at all. What happens is that this algorithm, and that's what the blog post is explaining, does not produce equally likely outcomes. So basically, if you run it so many hundreds of times, some outcomes have equal probability, like having 3, 1, 2, and in this case you're just shuffling the numbers, not the actual cards. The outcome 3, 1, 2 has kind of the same probability as 3, 2, 1, and some other outcomes have a lot higher probability. So even in the case of shuffling 3 numbers, we see that this naive algorithm is not producing equal outcomes. So there is no, the distribution of outcomes is not uniform. And it goes on to study why and explain why. And this is a great blog post that I would advise to anyone who wants to be aware of algorithms and the care that needs to be taken when you are creating algorithms. So, in short, if you created an algorithm, you have to be careful and sort of scientific to check that this algorithm does what you think it is doing or what you want it to do. And sometimes it goes well beyond like basic doing the most common sense thing that you could do. So the actual good algorithm is not much harder than this at all, but it has an important distinction and also actually a proof that it works and it produces equally likely outcomes, as opposite to their naive one, which doesn't. And I guess that's it for the video.